Well, hello there.
Hello? Hey, Mr. Mills.
Yeah.
What did you have to do to make this coffee this morning with the water? What did you have to do with the water?
Heat it up.
Until it
Almost boiled, yeah.
Yeah, until it boiled, right?
Yeah.
So we're going to talk about in this lecture vapor pressure and what boiling really actually is.
Ooh, change of definition
Yeah.
for sure.
Boiling is like, oh, well, it turns from a liquid to a gas.
Dude,
Duh.
it bubbles.
Yeah, but we're going to say why.
Right. And
What's really going on?
Right, and when we get water to boil for you at room temperature, it'll really hit home.
Sure, I hope
You know
so.
what I found
Because
today?
it's boiling, but it's not hot.
You know-
What? Ah!
You know what I found in my room today?
What?
A bell jar and a pump.
Really? Awesome. You can do it in here then.
I can. I don't have to borrow yours.
Nope.
So first, the new definition.
Mm-hmm.
Let's get right to it. Boiling only occurs when specifically the vapor pressure equals or exceeds the atmospheric pressure.
And I like this picture because it shows you
What these things are.
atmospheres always pushing down.
Yeah.
One atmosphere
I like
here.
to think of it as like this column of air from
top
top
of the universe, top
up
of
to the top of the
stratosphere,
atmosphere,
top, tippity top.
pushing down on me
It's pushing down on every square inch
of everything.
all the time.
And you wouldn't know it because your entire life you've
been
had
around
it.
it. You
So
can
you don't notice
feel pressure change when
Oh,
you
and right
hold.
in your sinuses. Even
Sometimes there's a
when-
few situations when you're going up and down big hills and mountains.
ears.
You can feel the pressure changing a little bit. Or when you go down to the bottom of a swimming pool, holding your breath and going to the deep end and try to get to the bottom, you feel pressure pushing down on
That's
you.
more water pushing down.
Because not only is the air on top of you, but there's, 10, 15 feet of water too. And water is obviously more dense than air.
It's much heavier.
So it puts off more pressure. But we're talking about gases here. A liquid trying to turn into a gas.
Yeah. So, let's little bit of pregame.
Mm-hmm.
What actually is pressure?
Well,
I'm under pressure to get an A, mister.
that's not the same kind of pressure that we're chemists are talking about.
No. We're talking about like literally pressure.
Like-
Pushing.
At the atomic level, these gas particles zipping around in straight lines and they're hitting stuff.
That would be the side of the container that the gas was
Yeah.
in.
So if
That's
this
me.
is the side of the container. My fists are gas molecules.
Yep. Here we go. Yep. Good.
The more they hit the side of the container, the faster they do it, the more
Right.
pressure they
And now
exert.
the colder it gets, the slower that happens. Because remember, heat is just kinetic energy.
In motion of atoms. So heat makes the atoms move. Atoms hitting walls of sealed containers creates pressure.
Pressure.
So
It's
that's
that
what
collision.
pressure is.
We talked about KMT, but that's
Yep.
not collision theory. We haven't
Nope.
talked about collision theory.
Nope.
But that is a collision. So there you go.
How do you measure pressure?
All right. Well, there's some units.
Mad many.
Yeah. So atmospheres, ATMs, we talked about that.
Mhm.
KPAs come up in the vapor pressure.
Standard temperature pressure.
Yeah,
Yeah.
that too. But it's going to be KPAs is in the next piece where we do our
Mhm.
actual. Then we'll find torrs and
Torrs.
millimeters of mercury.
And in your shop classes or other stuff, or even at home, you'll see PSI,
Yeah.
pounds per square inch.
You'll see that one a lot.
Strictly English unit that
Yeah.
Americans
Yeah.
use a lot.
You'll see torr and millimeters of mercury sometimes on the news when we talk about pressure, air pressure.
Yeah, and in the weather.
Yeah, the weather.
weather.
Yep, yep.
Bar sometimes. There's a lot of mad many units for measuring
True.
basically the same thing.
Little review, standard temperature and pressure then. So our standard base units, 0 degrees Celsius and 1 atmosphere.
Mhm.
And remember that 1 atmosphere equals 101.3 kilopascals, KPA.
Right.
Pascal was French? Was
Yeah,
he French?
Pascal sounds like
I
French.
think he was French.
Mm-hmm.
He was,
I forget his first name, but studied gases and pressure.
Did
Got a unit named after him. So
So-
was Tor. Tor was Torricelli. He was an
Right.
Italian guy.
Yep, he was.
Anyways, sorry, I digress.
Atmospheric pressure then is specifically the pressure that's created when the atmosphere is pushing down on me. Gravity is pulling that matter down, just like
Mhm.
everything else.
Exactly. And the reason why you don't feel it is because your body grew up and evolved in this.
Yeah,
It's
there's-
literally designed to
handle this
handle it.
particular pressure.
Right.
Okay.
Mhm.
Now, vapor pressure now is the opposite direction.
Right. So the atmospheres are pushing it down.
Right. But then I got a liquid.
Or a
and-
solid. Solids can have them too.
Right, but we usually use liquid.
Yeah.
And at the very surface, it's trying to go up into
Right.
vapor.
Right.
So we get this vapor pressure pushing up.
Atmosphere pressure pushing down. It's a push. It's not a tug of war. It's a push
Of
Of
war.
war.
It really is.
Yeah.
And now the water or liquid, I'll just use water as an example, doesn't start to boil
until it's stronger. One hand pushing down, two hands pushing up.
till the up equals or beats the
The
pushing
down.
down.
Right.
That is the real definition of boiling.
And the interesting thing is atoms and molecules on any surface, even a solid, are kind of trying to push up.
They really are.
And
They
so
want to break free.
they want to break free, and the atmosphere is pushing them down, kind of keeping them back in their place. So different substances have different vapor pressures.
They do because of their intermolecular forces.
So how the different molecules act. The sticky ones want to stay together. They don't have much vapor pressure.
Right.
The ones that don't, they're not sticky. They're like, screw you guys, I'm going home.
See. Right. So normal then is basically what is the vapor pressure at standard conditions.
Right.
So if I'm at 1 atmosphere or at that dotted line, 101.3 kilopascals,
Normally.
normal boiling point.
Right.
Good.
Every liquid has a normal boiling point.
Which just means where is it? Or what is it at the normal standard temperature pressure?
What temperature will it boil at if we're at 1 atmosphere like that?
Right. And then the boiling point of a liquid will change as pressure is exerted on it. So the more pressure I put in on it, pushing down, the hotter we got to get it.
Have you ever been to Colorado?
I have actually 4 times.
And you ever tried to cook pasta in Colorado?
Doesn't work good because water boils at like 88 degrees Celsius.
So what you mean to tell me is that if you're cooking dinner in Colorado, there's less pressure pushing down,
Because you're higher up.
so the water boils quicker at a lower temperature, which doesn't help the cooking situation when it comes to cooking noodles,
No.
because it takes longer. It's not at 100 degrees; it's like 80.
By the time you get it kind of cooked, it's so mushy you don't even want to eat it.
Yeah. So
So
this chart shows us normal boiling point.
for 4 chemicals,
Mm-hmm.
okay, and when we say normal, we've been trying to hit this a lot. This dotted line is 101.3 kilopascals. So this is the normal 1 atmosphere of pressure. That line right there.
And so the way you read it is, okay, if I know I'm at normally 1 atmosphere of pressure, I see where my chemical of interest touches that dotted line.
And go down to
read
temperature.
down to find the degrees.
That would be the
temperature.
boiling point at normal temperature. And if we did it for water, you'd see that we're going to hit 100 degrees Celsius, which we knew was the normal boiling point of water. If I increase the pressure, I will increase the boiling point. If I decrease the pressure, I will decrease the boiling point. So pressure really plays a big part. We're going to do 2 quick examples of how to do this, and we'll move right along. So first off, vapor pressure of water at 50 degrees.
I'll do this one.
All right, you do this.
So vapor pressure of water at 50 degrees. So I got.
So let's
50.
define 50,
There's
and let's
50.
go up until we hit the water line.
Water line's right here.
Okay,
So now I rise up until I hit that line.
and now we're going to read
over.
across. Approximately is that 5?
5, 10, 15, 20, 25. Nope,
Nope,
25 is
so 10.
too small.
So it's 10.
10, 20, about 10 kilo
Approximately 10
pascals.
kilopascals.
Mm-hmm.
Good. 10.
Gotcha.
Okay, another example. I think I stuck with water. Well, let's do water at 80 degrees. What is the vapor pressure? So now we're going to find 80 degrees, go up to the water.
These are increments of 5. So
Yep.
there's 80.
Yep.
And there's water line again. So I'm going to go till I hit that line. Right there. And then I trace over. Stay in the middle.
Right, so
Well-
it's just a little bit over 45.
It's
Or
between
little
40,
40.
and 50. I'm going to split the difference, call it 45.
Okay. I'll take that. A little
Because-
reason and logic,
This is not exactly calibrated.
right? And that little squiggly in front is a mathematical symbol that means approximately.
Yeah.
So you're going to have a range there, but you're going to find that when you get problems from us, we're going to try and pick ones that are really pretty obvious that it's right on them.
So just a message, the reason kids get tripped up on this is because of the tracing the line on the graphs and
Oh.
the scale. That 10 on the y-axis and 5 on the x-axis. Pay attention.
Quick math. Figure out what the 2 units are that you see, the 2 numbers.
It's like
How
playing
many are in
Battleship
between?
too. You know,
Yeah.
you trace up to hit the line, trace over. Or if you're given a pressure, you trace over, you hit the line, and then you retrace down. It's just back and forth like that to get
But it's
up.
real mad easy. There's 1 page of practice. There's 5 problems on each chemical or so. So 20 quick problems of doing this and you're done. All right? See you.
I can push the button.
Push the button. Push the button also.